Hello students, today we will solve the question number 4 and the question goes like this. 4 charges are arranged at the corner of a square ABCD of side D. As shown down, find the work required to put together this arrangement. Charge Q naught is brought to the center E of the square, the 4 charges being held fixed at its corner. So how much is the extra work which is needed to do this? We aim to find the work done for 2 cases. In the first case, we are bringing all these charges at point A, B, C, D, and in the second case, we are bringing one extra charge Q naught at the center of the square. First of all, we will understand the demand of question and how we are going to fulfill this particular demand. Okay, then we will go for the solution. So understanding what they aim at telling us is that we got 4 charges, Q1, Q2, Q3, Q4. In this, Q1 is positive, Q2 is negative, Q3 is positive, Q4 is negative. So these are the 4 charges we are having. Now these 4 charges should be placed with respect to each other in such a manner that they form a square, and the side of square should be D. They should be D distance apart from each other on the all 4 sides. So if we are taking this as A, B, C, D, we will place a plus Q charge over here, minus Q charge over here, again a plus Q charge over here, a minus Q charge over here. Okay, now to bring these charges in this configuration, we need to do some work, and then once these are brought in this diagrammatic format, we will, like this, all charges will be held together. We will not give any external force or energy. Then they will be in a static position. In such a way, these all will show a little equilibrium. Now, understanding this one more concept of diagonals, A and C are diagonal to each other. A, C and B, D. What are they? These are diagonals to each other. Diagonals to each other. Now, the thing which we aim at finding is this distance, the diagonal distance of BD and the diagonal distance of AC. For finding the diagonal distance for AC, diagonal distance for AC, we have this A, D and C. This is D distance, this is D distance. Using the Pythagoras theorem of right angle triangles, what we will get is that AC square equals to AD square plus DC square. D square will be AD square will be D square, DC square will be D square, and these will give us 2D square. This is the value of AC square. Now what is the value of AC? Under the root of this, 2D square, and we will receive D under root 2. That is the value of AC. AC is D under root 2. Similarly, the value for DB will be in the similar fashion, AB square plus BC square and these both are d square, this will be under root. Same Pythagoras theorem we are using, d under root 2 will be the answer. So this will also come d under root 2. Okay, this distance should be known. This is d, this is d. Now when we are bringing q1 to this point A, there is nothing at point B. At this point, these points are vacant. Points C, B and D are vacant when we are bringing charge number q1 to point A. So work done to bring this over here, work done equals to 0. Now we are having charge q2, negative charge, okay, and to bring this over here, we already have a occupied space. The red mark is occupied with q1. So due to this occupied surface, we will do some work to bring this charge at point B, So that work will be done as k q by force into the particular distance. This is the distance, okay. So force into that particular distance. Now similarly, this we will give as work done to bring some charge at point number B. We will not write the values at present. We will understand the values when we will solve the question. Now first of all, we will understand the demand of question here. So I have told you all these things. Now we are bringing q1 at A, work done is 0. Now we are bringing q2 at B. Here the work done at B will not be equal to 0. It will be equal to some work done, that is with respect to A, due to presence of charge at point A. Now this is also occupied. Now we will aim to bring a charge q3 to point number C. So again there will be a work done. When this will be occupied, again there will be a work done, and that work done at C will be equal to due to presence of charge at B and at C. From here to here we will define as D, and from this point to this point we will define it as d under root 2. Okay, now this is also occupied. Now we aim at bringing our fourth charge minus q4 to the position number D. Here the work done will equal to work done due to the presence of charge q1, then work done due to the presence of charge q2, and then work done due to the presence of charge q3. So all these charges will affect the presence of the charge over D. Then the charge will come here, and we will be aiming at this particular distance D, and the distance from B to D, that is d under root 2. So in the first case we will find these work done. Now the total work done to bring all these into the square format. Total work done to bring all charges in square configuration equals to work done at position A, then work done at position B, plus work done at position C, plus work done at position D will give us the total work done, W total. ठीक है? Now next, the B part of the question. B part of the question. It states that in this particular square, wherever these diagonals meet is the center. Wherever these diagonals meet, it is the center. It is the center of our square, and here we are placing a charge Q0 or Q naught or 0, a charge we are placing over here. And what do we have on these particular points? We have here Q1, Q2, Q3 and Q4 respectively. Q1, Q2, Q3 and Q4 respectively over all these 4 points. Okay. So we need to find work done in bringing Q naught at the center of the square. Now see, there is a force which will be applied in this direction. See over here, from Q3 a force will be applied in this direction. From Q1 a force will be applied in this direction. From Q2 force will be applied in this direction, and from Q4 force will be applied in this direction. So one thing which is clear for us is that from Q naught, point A, B, C and D are equidistant. How much is they? They are half of the diagonals. What is the value of our diagonals? It is D under root 2. So what is the distance from A, B, C, D to Q naught? It is D under root 2. This is the distance. Okay. So all are having same distance. The charge will, the force from Q1 will be equal and opposite to the force from Q3, as both are having same magnitude, same this one, the direction is in this for one and other for this, so both have opposite direction but magnitude is same, so they will cancel out. Now force due to Q2 is equal and opposite to the force due to Q4, and hence it will also cancel out. So the force exerted on the center part will be 0. So the force on Q naught will come to be 0. Why so? Because other forces F1 cancels out due to F3, F2 cancels out due to F4. Okay. Therefore, this particular charge Q naught do not need any work done to bring it to the center of our square. So this is the fundamental of this question. We will be using all these in our solution of the question. So now let's come and see how we are solving it and what all are the values we are getting to solve it. Okay. So we have understood the basics of our question. Let's read the question once again and then we will start the solution of our question. 4 charges are arranged at the corners of a square ABCD of side D as shown down. Find the work required to put together this arrangement. The charge Q naught is brought to the center E of the square for 4 charges being held fixed at its corner. How much extra work is needed to do this? Now the solution states, Work done is calculated for keeping the charges in the given position, for not bringing them to this arrangement. So work done in bringing the charge Q naught to A is 0. No charge is present in the given surrounding, so no work done. No work done. Next, work done in bringing the charge minus Q to B when Q plus is present at A. Charge at B into electrostatic potential at B due to charge plus Q, which is present at A. Okay, electrostatic potential is V and it is given by the formula K Q upon R, where Q is the charge, R is the distance between the charges. Here the value of Q is plus Q. Here the value of Q is plus Q. This is the Q which is affecting the B. Okay. Then for the C it will affect in this direction and B will affect in this direction. And for D, B will affect in this direction, C will affect in this direction and A will affect in this direction. Okay. So this is here, over here R is equal to D and this is our potential, electrostatic potential at B. So that is multiplied with the charge at B. That's how we give work done. Work done equals to charge into potential. I have taught you already when we were learning about the electrostatic potential how to derive work done. So we applied this formula and this is what the value of work done we have received. Value of work done, that is minus Q square divided by 4 pi epsilon naught D. Here K ka value is 1 by 4 pi epsilon naught. Next, work done in bringing the charge plus Q to C, when plus Q and minus Q are on A and B respectively. Now there are two charges. When we brought at A, no charge. When we brought at B, charge at A was there. Now we are bringing at C. So the charges at A and B are present. Now charge at C, Q at C into the potential due to A and due to B. How we are finding the potential? Here we are using superposition principle. Superposition principle. Because it is a system of charges. Only two systems are not under the consideration. We are using a system of charges. So V total equals to V A plus V B. Okay. Q at C is plus Q. Then potential due to A. Potential due to A is given as plus Q by 4 pi epsilon naught D by D into under root 2. What is the diagonal distance? We have read the diagonal distance is D into under root 2. And what is the potential due to B? Due to B, it is minus Q by 4 pi epsilon naught into D. That is the distance B and C. A is over here, so it is a diagonal distance. Okay. So plus Q by 4 pi epsilon naught D under root 2 minus Q into 4 pi epsilon naught into D. After solving it properly and extracting out the common values like Q, 4 pi epsilon naught D, 4 pi epsilon naught D, we received a value like, we took minus out. When we are taking minus out, there will be one minus left for this and this minus will go out. So here this is the common minus out. 1 minus 1 by under root will be the under bracket. How did we get this? I will show you the solution over here so that it's actually better understood to you how we got it. Okay. See it. Work done equals to plus Q into plus Q by 4 pi epsilon naught into D under root 2 minus like we are adding it, but our charge is minus 4 pi epsilon naught into d. We are multiplying the whole equation by minus 1. We will get W equals to minus Q into minus Q by K d under root 2 plus Q by KD. What is K here? K equals to 4 pi epsilon naught. Okay. This is the value. Now we will extract out all the Q's. Minus Q is extracted out. We will not do this one step over here. We will not multiply. Instead, we will take it out. Because once we are multiplying, we are getting the same in the negative values, and we do not need it in terms of negative value. We want to define it in terms of the positive value. So after doing this, we will take out this K and Q. Okay. We will take all the Q's out. What will be left inside? We will take 4 pi epsilon naught also outside. 4 pi epsilon naught d. We are left with, just a minute, we are left with 1 upon under root 2 minus 1. Okay. Now if we take this minus out, W will come around this upon 4 pi epsilon naught into d. Here the minus will be introduced and here it will be plus 1. Now we will take the plus 1 in the front and minus 1 at the back. W will be equals to minus Q upon 4 pi epsilon naught d into 1 minus under root 2. So that's how we are getting this value. Now we will deal with the d. Work done in bringing the charge minus q at d when plus q, minus q and plus q are present at A, B, C respectively. Now again I am drawing a small square for a better understand. From A, force will come in this, from B force will come like this, and from C force will come like this. So for AD, D, for CD distance D, but for BD the distance will be D under root 2. So charge at D, that is minus Q, potential at D due to charges at A, B and C. For A, we have potential equals to K Q upon D. For B, we have K minus KQ by D under root 2. And for C, we have KQ by D. So for C and A, potential are same. So it will, for A plus C, it will come to KQ by D, whereas for B will remain as KQ by D under root 2. Now we will take all our common values outside as we did in this step, and we will receive this particular value for the work done. Work done will come around W equals to minus Q square by 4 pi epsilon naught into D into 2 minus 1 by under root 2. Okay, this is these two values are little uncommon, so they left in the bracket, and this is our common in all the components. Now the total work done is work done in step 1, that is 0, work done in step 2, which is normal QV, work done in step 3, it is Q into V plus V, and step 4 it is Q into V plus V plus V. This is 1, 2, 3, 1, 2. There are not same V's, na? This one is due to A, this one due to B, this one A, B, C. Okay, this is the work done over here. So we will substitute the given values here. Whatever values we receive, 0 for point A, minus q square by 4 pi epsilon naught for point B, minus q square by 4 pi epsilon naught d into 1 minus 1 by under root 2, that is for C, and then the last terminology minus q square by 4 pi epsilon naught into d into 2 minus 1 by under root 2 for the d. Here what we are saying is that minus q square by 4 pi epsilon naught d is common. Common value over here is k q square minus k q square by d. Here k equals to 1 by 4 pi epsilon naught. These are the common values and these are the uncommon in the bracket. So we are solving the bracket over here to find a minimized solution or a well solved solution. So we will see how the bracket values are being calculated and how we reach to the conclusion that it should be minus q square by 4 pi epsilon naught d into 4 minus under root 2. So first of all we will write all the values inside the bracket as 0 plus 1 plus 1 minus 1 by under root 2 under the brackets plus 2 minus 1 by under root 2 under the bracket. Okay. So now opening up all the brackets, we will get 0 plus 1 minus 1 by under root 2 plus 2 minus 1 by under root 2. Here values are this and this, under root values are this and this. All are having same sign. These values are having same sign, these values are having same sign. So they will get added up. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 2 is 4. So we got 4 minus 1 by 2 plus minus 1 by 2 is 2 times 1 by under root 2. So this when it is solved it will come 4 minus under root 2. That is how we are getting the values of the bracket. Hence the total work done equals to minus q square by 4 pi epsilon naught into d multiplied by 4 minus under root 2. Okay, this is the work we have done to bring the charges plus q minus q plus q minus q at the position A, B, C and D respectively to form the given configuration of this square. Now we will move to the B part of our solution. The work done depends upon only the arrangement of charges. But not how they are assembled. We can assemble them by kicking them, by bringing them with love, or by forcing them to come to this squared configuration. But where does we need the work done? It depends upon the arrangement. To bring it into that arrangement, from here from these points we can bring them however we want. But to keep them in the disciplined square format is the point where we need to put our work. So in this school, what happens? You will get admission in this school by your parents. If your parents are not free, then your elder sibling will go and do the procedure. In case your elder sibling is not there, your relatives will do it. So somehow by this or that you are getting admission in this school. But now coming to the school on the proper timing, studying and then learning new things and going back at home on the same time, on the needed time. Like if your school starts at 7:30, you should be there at 7:30, and if it ends at 2:30, you should be at home by 2:30. This punctuality and discipline and series of how to do the work is taught by the teachers in the school, and here is where our teachers play an important role. It's not in the admission. Teacher will never go to your home and will ask you to get admission in the school. That is done by some external forces. But to make a disciplined schedule of a student is where teacher plays important role. So to bring these in a disciplined schedule of our square shape is the point where we need to work, okay. And by definition, this is the total electrostatic energy of the charges. This electrostatic energy, when balanced, then only these will stay at the point. If some charge is giving us extremely higher electrostatic energies, the other charges will fly over. See, if there is a force, the water is coming to you by some force, you are a heavy body, of course humans are so heavy, so a very small layer of water will not flow you, but it is coming very heavily. What will happen? You will flow in the direction of the water flow itself. You will not be able to move against the water. Same thing is electrostatic energy. These electrostatic energies are kind of water flow, heavy water flow. If they are not regulated with each other, these from any one point source can make the other sources, other charges to fly. Like you can do a experiment with the magnetic. Try to bring a north and a north pole together. How will the magnet A will start moving? It will start moving as in if some kind of ghost is running behind that magnet. So it will never come in contact with the magnet B. So that is the force, the same force. In the magnets on macroscopic level we can see the force, but in charges we cannot see. Such forces of repulsion are there in the charges also, and these are all due to the energy held by that charge. Now bring us north and the south pole together. What will happen? They will attract, and they will attract by a by simply coming with the speed of light. Dham. That is how they get attracted. That is how much energy they are storing in themselves. That is how much force they are exerting on the poles. So you cannot think of that sort of magnitude of forces which are being which are being experienced by these poles, these charges, negative negative, positive positive, and negative positive charges. These are very high magnitude charges. So like just do simple, very simple experiment with the magnet to understand how much force they have. We will now move on to the next part, B, where in this particular system of charges A, B, C, D, at E we are bringing our Q node. E is present at the center. E is present at the center. Okay. Extra work done. Extra work done in bringing the charge Q node to point E. Q node into electrostatic potential due to point A, B, C and D at point E. So Q node into this, and this. These two values are same. These two values are same. Same. 1, 1. Now these values are same, same. So I have numbered as 2 to y, because to understand these are equal. Okay, how does it is coming is I will explain. See, this is our square, this is d by under root 2, this is d by under root 2, this is d by under root 2, and this is d by under root 2. So distance from E to A, B and C and D equals to d by under root 2. That is half of the diagonal value. Half of the diagonal value. Okay. Now potential due to A will be plus Q by 4 pi epsilon naught into the distance. Distance is d by under root 2. Potential due to C is also same as this. Now potential at B is same as potential at D equals to minus Q upon 4 pi epsilon naught into d by under root 2. So now when these are summed up, what we will get is this is opposite to this. V of A and C is equal and opposite to V of B and V of D. Equal and opposite. So these will cancel out. This will cancel out with this will cancel out with this. Same number of, like 2 minus 2, what is the value? 0. Same is happening here. 3 minus 3 is 0. So we are having same amount of potential from B and D and A and C. So all these cancel up to give us 0. So anything multiplied with 0 multiplied with anything gives us 0. So the whole potential of ABC comes to be 0, and that is multiplied by Q naught, and it will give us the value of 0. Q naught into 0 will give us 0. So the work done comes around to be 0. As work done is 0, to bring the charge to point E, since potential due to A and C is cancelled by that due to B and D, because they both are equal and opposite in nature. So that's how we are solving a question for a system of charges. Giving the appropriate distances and understanding the distance plays a very much important role in understanding it and finding out the work done. And to find out the work done, we have this particular relation with the potential. One should never forget work done equals to QV. Okay. And other relation is with force, that is F into S, force into distance or displacement, force into distance or displacement, anything. This was used in the previous chapter where we have defined the force. As in this chapter we have defined the potential, we tend to use work equals to QV for solving various questions. So that's all for the today's class. We'll meet up in the next class with a new concept. Till the time, bye bye, have a good day.